Anti-aging science often promises big things: longer life, fewer diseases, stronger muscles, sharper minds. But there's one uncomfortable truth hiding beneath the glossy headlines and centenarian interviews. Much of this research is about as diverse as a bowl of plain yogurt in a Zurich clinic. While biological aging is a universal phenomenon, the way we study it and the populations we choose to represent humanity's aging process are anything but universal. Take a casual stroll through the literature on epigenetic clocks, caloric restriction, omega-3 supplementation, or senolytics, and you'll notice something curious. Many of the studies are based on small, relatively homogeneous cohorts: Swiss retirees, Scandinavian twins, white Americans with access to preventive care, or even worse, laboratory mice with Ivy League pedigrees. And while these groups are certainly convenient, clean, and compliant, they don't even begin to capture the full spectrum of human biology or the social realities that shape how we age. This lack of diversity isn't just a statistical oversight, it's a scientific blind spot with real consequences. Human aging is shaped by a complex stew of genetics, environment, diet, stress, pollution, microbiome diversity, and socioeconomic context. If your sample population has access to fresh produce, universal health care, mountain air, and Pilates at 70, of course they're going to age differently than someone growing up amid urban smog, high stress, food deserts, or chronic underemployment. And if your epigenetic clocks or biomarker baselines are based entirely on that first group, applying them globally is like calibrating a GPS using only traffic data from Geneva. Consider the fascinating, if frustrating, case of epigenetic clocks. These tools are wildly promising. They predict biological age by measuring DNA methylation changes. But most of the training datasets for these clocks come from people of European ancestry, with consistent lifestyles and relatively low environmental variability. When researchers try to apply these models to people of African, South Asian, or indigenous backgrounds, the results can be skewed or unreliable. That's because epigenetics is sensitive not just to chronological age, but to the lived experience of the body, including diet, exposure to pollutants, chronic stress, and even trauma. A universal methylation pattern doesn't exist because a universal human experience doesn't exist. This extends beyond methylation. Take telomere length, another popular aging biomarker. It's shorter in people exposed to chronic stress and systemic discrimination, but it's also genetically determined to some degree. Different ethnic groups have different baseline telomere lengths, meaning what looks short for one population might be completely normal for another. Without population-specific reference ranges, using telomere length as a predictive tool becomes a shaky business. Or let's talk about omega-3 fatty acids, a darling of aging research. We know omega-3s can reduce inflammation and support cognitive health, but how they're metabolized varies based on genetic polymorphisms common in different ancestries. The FADS gene cluster, which influences how we convert plant-based omega-3s into the long-chain types our bodies need, varies widely between populations. Someone from East Asia may process algae oil differently than someone from Northern Europe. But many omega-3 trials don't even stratify their results by ethnicity. Instead, we get conclusions that sound global, but are based on extremely narrow biological assumptions. Culture and diet also play a huge role in aging, but they're often reduced to side notes in large studies. A Mediterranean diet is frequently held up as the gold standard for longevity. That's great, unless you live in a place where olive oil is a luxury or fish is scarce. Likewise, practices like fasting, herbal supplementation, or fermented foods have deep roots in non-Western cultures, yet they're often excluded from mainstream anti-aging research, not because they don't work, but because they don't fit the biomedical mold or can't be easily patented. Even the social dimension of aging varies. In some cultures, the elderly live with extended families and remain socially embedded late into life. In others, isolation is common. Social engagement profoundly impacts cognitive resilience and even immune function, yet many anti-aging trials are conducted in individualistic societies where loneliness at 70 is seen as normal, not pathological. So what's the solution? For starters, more inclusive research design. That means recruiting diverse participants, not just in terms of race and ethnicity, but across geography, income levels, diet, stress exposure, and cultural practice. It also means developing population-specific models of biological aging, instead of assuming a Swiss or Californian standard is globally valid. It means funding research in parts of the world that have been historically ignored in geroscience, including Africa, Southeast Asia, Latin America, and indigenous communities in North America and Australia. And while we're at it, let's broaden the definition of what counts as evidence. There's wisdom in traditional practices like Ayurveda, traditional Chinese medicine, or African plant pharmacology that may intersect meaningfully with aging science. These systems may not always meet the gold standard of Western randomized controlled trials yet, but they often reflect centuries of observational insight that shouldn't be dismissed out of hand. Ultimately, aging is both a biological process and a social story. If we want to slow it, reverse it, or make it more graceful, we need to understand it in all its global complexity. Right now, anti-aging research risks becoming a tale told by a few, about a few, for the benefit of a few. But with broader inclusion, it could become a truly human endeavor, one that not only extends lifespan but uplifts the quality and dignity of aging for everyone, everywhere. Because let's face it, we're all headed in the same direction. We might as well compare notes.